Okay, we're going to do another example of a proof involving angles, and this is our second example of this. Geometric proofs are very important. Sometimes it's important just to be able to prove theorems, and sometimes we have proofs that are a little bit beyond theorems. As you can tell, the Common Core standards show that the proving of theorems is very important. The proof we're going to do this time is if L is parallel to M, and 5 is supplementary to 4, then show that A is parallel to B. So we're trying to show that A is parallel to B on this problem. And so we always start, and I'm going to do column proofs here, by listing out your given. And if you've done one of these before, you would know that the given statement is always the hypothesis or if part of a conditional. So in this case, it's L is parallel to M and 5 is congruent to or is supplementary to 4. And that is always our given statement. Now, I usually advise my students to go through and decide, at least what can I do? And then if you can't figure out what to do, then you go back to your given statements and just start writing stuff down until something kind of comes clear or breaks a little bit free in your brain about how to get to this proof. But I'm given that 4 and 5 are supplementary, and I'm given that L is parallel to M. So because L is parallel to M, that means I know things about one of these angles on line L and one angle on line M. So I know there's something going to be special about those angles. Because I'm using supplementary, I think it's probably a good idea to use this idea of supplementary. Because if I can show, there's a very important theorem called Congruent Supplements, that if I can show two other things are supplementary, and I can show that two of those, the elements in the two supplementary statements are congruent, then I can show the other two are congruent. And showing things as congruent is always a good idea. To prove that A is parallel to B, it would be enough to show, for instance, that 1 and 4 are congruent, or to show that 3 and 4 are supplementary. 3 and 4 are same side interior, so if they're supplementary, then the lines are parallel. 2 and 4 are alternate interior. If I could show that 8 and 4 are congruent, then that would be enough because they're corresponding angles. So those are kind of some of the ideas. If I could show that, for instance, well, that would be about it. I could do 1 and 6, but I don't want to do that because I know I need to use 4 based on my given. So looking at this, one thing I think is probably a good idea would be to do a supplementary statement based on the supplementary statement I have right here. And so in doing that, the one I see that would be a good idea would be 5 and 6. Right? That's all I really know about either 4 or 5 on this picture. And so I'm going to start by saying angle 5 and angle 6 are supplementary. And I know that because linear pairs are supplementary. The reason I started there is just because I was looking to try to use the congruent supplements theorem because it's such a good idea. And on this, I can now use it because 4 and 6 are both supplementary to 5. I can claim that 4 is congruent to 6. That's the congruent supplements. If two angles are complementary to the same angle, then they are congruent. Or supplementary to the same angle, then they are congruent. And so the congruent supplements allows me to write 4 is congruent to 6. Now that I have 4 congruent to 6, that seems like a good idea because, again, I said one of the ways I could do this is to show 4 is congruent to 8. Well, I don't know anything about 8 yet, but I do know something about 6 and 8 because L is parallel to M. And so I can say angle 6 is congruent to angle 8. And I know that because of the corresponding angle postulate. The corresponding angle postulate says if two angles are corresponding, then they are congruent as long as the lines are parallel. And since L and M are parallel and 6 and 8 are in the same location on transversal A, they're both top right, that means they're corresponding, that means they're congruent. Now hopefully you can see that angle 4 is congruent to angle 8 by the transitive property of congruence. The transitive property of congruence is always our friend, a very powerful theorem. We try to use it all the time. Anytime you're trying to show two things congruent, transitive property is going to be a nice way to get there if you can use it. It's something you should look for. Just like the congruent supplement should be something you look for if you're given a statement and you're given about supplementary angles. And then that is enough now that I've shown 4 congruent to 8. Well, I can say now make my claim that A is parallel to B, and I can do that by the converse, the opposite, of the corresponding angle postulate. And that says if two lines are cut by a transversal and corresponding angles are congruent, which 4 and 8 are, then the two lines that are cut by the transversal are parallel. So I showed that 2 corresponding angles are congruent, so that's enough to say that the 2 lines are parallel. Again, another way you could have done this is to shown 5 congruent to 7 and 7 congruent to 3, and then done a that means that measure angle 5 equals measure angle 3, and done a substitution into this one for 5, and then you would have been able to get to measure angle 3 plus measure angle 4 is 180, which means 3 and 4 is supplementary, and then by same side interior angles, the lines are congruent. Another thing you could have done is at this step, instead of doing 6 congruent to 8, you could have done 6 congruent to 2 because of alternate interior angles, and that would have been enough as well. And then you've done the proof to show 2 and 4 congruent, which by the converse of the alternate interior angles theorem, you could have gotten there. So I hope that makes some sense. Again, remember, the key to always doing proofs is to write down what you know, and then to show, to look at the picture and try to find some, give yourself an idea of a path that can get you to your answer.